Hey physics class, so today we're going to be talking about the problem of how much force is actually going through your shoulders when you're doing a push-up. So the way you want to look at this problem is with a right triangle with a small angle at the bottom, and you're going to need to consider the distance from your feet to your center of mass and the distance from your feet to your shoulders. So for this problem, as an example, we're just going to use a person who's 1.76 meters tall. Generally, your center of mass a little bit below your belly button, so for this person we're just saying 0.9 meters, and they have a mass of 75 kilograms. So the first thing you want to do while looking at this problem is you want to take the formula for virtual work. So virtual work essentially takes your mass times gravity, which is your weight, and it multiplies it by the distance traveled, so the distance that your center of mass will be moving up, which in this case will be small l sine theta d theta. But even though we have this problem and it gives us the work, that's not telling us the force that your shoulders are acting out, that's just telling us the force over the distance, so we need to equate that to something else that involves the distance from your feet to your shoulders. So for that, what we do is we take our original equation for the work done, and we equate it to force times the distance from your feet to your shoulders times sine theta d theta. And as you notice here, that means that then, in both cases, sine theta d theta, both sides will cancel out, and that allows you to simplify the equation a lot more and get it so that it becomes force equals mass times gravity times the distance from your feet to your center of mass over the distance from your feet to your shoulders. So, now that you have that formula, you can plug in all of our info that we have and do 75 times 9.8 times 0.9. Sorry for my bad handwriting, of course. And 1.5 meters for the distance between your feet and your shoulders. So, if you take that and calculate it real quick, you get 9.8 times 0.9 divided by 1.5. 441 newtons, which, if you divide that by 9.8, you'll see is about 45 pounds, which, if you divide that by 75, you'll see is about 60% of your body weight is what you're lifting and the force that you're putting out while you're doing a push-up. Thanks for listening.